All right, so let's talk about another use of the remainder theorem. So remember how we can find the zeros of a polynomial. Basically, you set it equal to 0 and solve for x. But this one's a little difficult to set equal to 0, right, and solve. Well, we can use a little hint and we can use the remainder theorem to determine if a number that we have in mind could be a 0. All right, so let's try to use the remainder theorem to determine if the square root of 3 is a 0, right? So basically, we want f of the square root of 3 to equal 0. And so one way we can check is to use synthetic division and see if we get a remainder of 0. So what we're going to do is use a square root of 3 in our box. Look at our coefficients. We got 1, 1, -3, -3. Everything was in order, so that's good. So I just use all my coefficients. Bring the first number down, and then multiply and add. So I need to multiply root 3 times 1, and then I need to add 1 plus root 3. Don't worry about trying to get the decimal. We don't need it. It's easier without. Okay, so then I need to multiply root 3 times 1 plus root 3. So root 3 times 1 is just root 3. Root 3 times root 3 is just 3. And so now I need to add -3 and root 3 plus 3. Well, the 3's are just going to go away. Multiply root 3 times root 3. Add -3 plus 3, that's 0. So we get a coefficient, a remainder of 0. So that tells us by the remainder theorem, we got exactly what we wanted. F of root 3 is 0. So root 3 is a 0. Or we could call it root of our function. So we can use it to verify that our zeros are correct. All right, next let's talk about another theorem. It's called the factor theorem. It's very close to the remainder theorem. So basically it says, oh, if our remainder is 0, right, if f of our polynomial is 0, then x minus c is a factor. All right, so remember, when you plug in a number and get 0 as our remainder, that means we have divided by x minus whatever our number is. Okay, and that's actually a factor. And it also works in both ways. So if x minus c is a factor, then f of c is 0. So let's talk about how that works. So it says use the factor theorem to determine, oh, this should say if. If x minus 3 is a factor of this polynomial. Okay, so let's check it out. All right, so how do we determine that? Well, let's see, can we divide this? Can we put 3, so remember it's always the opposite, can we put 3 in our box and get 0 as the remainder? Well, let's see. These look to be in the right order, so I'm going to put my coefficients here. 1, -1, -11, 11, and 12. Skip a space. Bring the first one down, and then multiply and add. So 3 times 1, -1 plus 3, 3 times 2, -11 plus 6, and we're going to keep going. 3 times -5, 11 plus -15, 3 times -4, 12, -12, 0. So we get 0 as our remainder. That's good. that means that x minus 3 goes into this function evenly. So that means it is a factor. So the answer to this question, to determine if x minus 3 is a factor, well, our remainder is 0, so that means yes, it is a factor. If our remainder was not 0, then it's not a factor. So the answer is yes. X minus 3 is a factor of our function. And I'll also show you how that works too, so you can see what I mean by factor. That means we can rewrite our f of x as a factored form. So we can factor out x minus 3, and what are we going to be left with? Well, we're left with the answer we got down here. All right, so this was a 4th power, so this is going to be a 3rd power. X to the 3rd plus 2x squared minus 5x minus 4. Alright, so this is a more factored form of the original function. So if you were to multiply this out, you should get this back again. Alright, let's do the last example. So last example, it says factor this function. We already know how to factor using synthetic division, given that -5 is a 0 of our function. Then we're going to solve the equation of our function equals 0, which again, this is difficult to solve because we don't know how to factor this. But we're given that -5 is a 0, so let's use synthetic division and then we can factor it on our own. Okay, so we're going to put our -5 in our box. Coefficients, make sure everything is there and in order. So we're going to use 3, 25, 42, and -40. Skip a space, drop the first one down. 3 times -5. 25 and -15, adding, we get 10. -5 times 10. Then we want to add 42 and -50. -5 times -8, that's 40. And then, of course, we expected to get 0 as our remainder because we already knew that -5 was a 0. So that tells us that f of -5 equals 0. All right, so how do we write this in factored form? F of x. All right, so if -5 is a 0, what's that factor going to look like? Well, we found that 3 is a 0 when x minus 3 is a factor. So -5 is a 0 if x plus 5 is a factor. So remember, we changed the sign here. And then what's the other piece? Well, we just use what we got as our answer. Reducing the power, so 3x squared plus 10x minus 8. So we were able to factor this even more. All right, so that's the first answer. We have factored our function. And we could also factor it some more. I'm not sure what Alex will ask you to do, but for part 2, we will have to factor it some more. So part 2 says we need to solve this equation. So the equation is 3x cubed plus 25x squared plus 42x minus 40 equals 0. Again, this is difficult to solve, but we know how to rewrite this using our factored form. This is the same as x plus 5 times 3x squared plus 10x minus 8, which is something a little simpler to solve. This is a quadratic. We can factor this, right? You can guess and check. You can use Xbox or quadratic to figure out the factors, whatever you want. Okay, I'm going to factor this out. This is 3x minus 2 times x plus 4 equals 0. So what does that tell us? We have 3 things multiplied by each other to equal 0. That means at least one of these is 0. So we're going to see what happens when all of them equal 0. X plus 5 equals 0, 3x minus 2 equals 0, and x plus 4 equals 0. So we get x is -5, which we already knew. from the problem. Also, x is 2 over 3. Also, x is -4. So here are all of our zeros. All right, so we use synthetic division as a tool to help us factor, and then we were able to set it equal to 0 and solve. All right, so make sure you're able to divide using long division and synthetic division, and then apply the remainder and factor theorems. And so if you could not do this and you have questions, make sure you ask me about it in class. All right, have a good day.